Hello to all my friends. In the continuation of the educational videos of the HiTek Studio software related to HiTek brand HMI, today we want to get acquainted with the communication parameters of this HMI and know how to define these parameters in this software. We want to connect these HiTek HMIs to the LS brand inverter through the Modbus RTU protocol under the 405 network and check the start frequency value and other things through the network. Alright, let's continue with the video and do this together. The first thing we need to do is get familiar with the ports and communication comms of the HMI panels. First, we'll create a project and select the type of HMI we want to program. For example, here the HMI I want to program is a 7-inch model. So, I need to see what communication comms the 7-inch model has and which networks each of these comms supports. To find out which networks each comm supports, after I create the project, I go to the project window and select the HMI settings option. When the page opens, in the description section, all the information related to the 7-inch HMI appears for me. So, when we want to know which networks the communication COM ports of this HMI support, we scroll down here and it says COM1 supports RS-232, 2-wire RS-485, and 4-wire RS-485, which is the same as RS-422. COM2 on this HMI only supports 2-wire RS-485 and COM3, network 232. So, if we want to see which network each COM port supports on HMI panels from HiTek, we need to open the HMI settings in the project section. Here, in the description section, it shows us which network each COM port supports. I confirm this. Alright, when you check the catalog for HiTek HMIs, you'll see that here, on each HiTek HMI, this DB9 port is for COM1 and COM3, and this 2-wire terminal is for the 485 COM port on this HMI. Let me scroll down. I can see the specifications for this DB9 port on the HMI. It has provided explanations for each pin. Now, for the 2-pin terminal related to 485, it says pin 1 is for the positive 485 line, and pin 2, which is the B terminal, is for the negative 485 line. So, in the catalog, you can also see what each pin is for. Alright, now I'm going into the software. So, how should I define these communication COM ports, and what settings do I need to configure for them? To define the HMI's communication COM ports, in the Setup section, we select the Communication Setting or Local Connection option. Here, a new window will open for us. In this window, we can define our COM1, COM2, and COM3 ports. Now, I want to connect to the LS inverter via the 485 network and exchange data. So, I go to COM2. I select COM2. Once I'm on COM2, I click on the Connect Device option here. I'm acting as the master, and my inverter is the slave. Okay, it asks which protocol you want to use to communicate with the LS inverter. I set this to Modbus, saying I want to do this through Modbus, and for the device type, I enter the addresses I want to send to the inverter in HMI, which are specific to my inverter. My addresses are in hex format. I confirm it. Okay, I set the station number on the inverter to 1. So here I also set it to 1, but the settings are for a 2-wire 485 network. On our inverter, we defined a baud rate, parity, stop bit, and station. We set the station here to 1, But what are the baud rate, data bit, stop bit, and parity on our inverter? Here, we'll open a picture. Take a look. This is on the LSS 100 brand inverter. When we want to set the station number, we enter it in COM01, and we specify our protocol type here as Modbus RTU in COM02. We set the baud rate on the inverter to 9600. Through parameter COM03, we define the data bit, stop bit, and parity bit as 8 and 1. That means our data bit is 8 bits. Our stop bit is 1, and our parity is none in COM-CM03. If we want to control start and stop through the network on this inverter, we need to set DRV to 3, and if we want to set the frequency through the network, we need to set FRQ to 6. Alright, I'm going back to the software. There, we had set our baud rate on this inverter to 9600. Here as well, it's 9600. Our data bit was 8 bits. Our stop bit was 1, and our parity was none. I click OK. Alright, I've finished the settings for COM2, which is related to the LS480 and 500 network. So, if we want to define the HMI communication ports, we need to go to the Setup tab, enter Communication Settings, and then Local Connection. Now, here I want to connect a HiTek brand HMI to this LS inverter and set up start/stop and frequency control. So, I'm going to draw a box here. Alright. For example, I'll set its color. Yeah, like this. Okay. I need to add a start button for the forward direction, a button for reverse start, a button for stop, and a numeric input value so I can set the frequency value for the inverter. So, what should I do? First, I'll bring in my start and stop buttons. I'll set them to bit set. I'll close this window. I'm playing word set. I'm saying, when I press this start button, the first button, for forward direction. Set the constant, assign a value to a certain address. Alright, I'll open an image here again. It's the same image as before. We make a series of settings on the inverter. Every inverter, every slave, has its own specific network addresses. Alright, in the S100 inverter, the network addresses for frequency and start/stop are as follows. The address for start/stop is address 5 hex, and the address for frequency is address 4 hex. This means that if bit 0 of address 5 of the inverter, address 5 hex of the inverter, is activated, if its bit 0 becomes 1, a stop will occur. If bit 1 is activated, that's forward, and if bit 2 is activated, that's reverse. Okay, 2 to the power of 0 is 1. So, for the inverter to stop, our bit 0 needs to be set to 1. 2 to the power of 0 is 1. We assign the value 1 to address 5. That's for stopping. 2 to the power of 1 is 2. We assign the value 2 for the inverter to go forward. 2 to the power of 2 is 4, for reverse. So, we need to assign the value 1 to address 5. For stopping, we assign the value 2 to address 5. For going forward, and assign the value 4 to address 5 for going in reverse. Let me go back to the software. Now, I want to set up the start button for the forward direction here. So, as we said, for the forward direction, we need to assign the value 2 to address 5 of the inverter. In my device, my addresses are no longer inside the HMI. That means I don't want to use the registers inside the HMI. I want to communicate with an external device over a network. So, I'll set this to COM2, which I've already configured. It will be set as Modbus 14 hex. After defining this device, it asks here, what is your address type? If you set it to 4x, you can perform both read and write operations. But if you set it to 3x, you can only perform read operations. Since I want to write a value to a specific memory, I'll set it to 4x. The address for start/stop in these LS inverters is address 5. So I said, when I press this switch, load the value 2 into address 5 hex of the inverter. Okay. I'll define a label for it as well. I'm forwarding this. And for its graphic, from the import graphics library, I'll choose a switch. For example, Alright. So this is the 60 forwards. I'll copy and paste another one of it. For stopping, we said we need to assign the value 1 to address 5 of the inverter. I click on this one. Here, I need to assign the number 1 to address 5 of the inverter. I click OK. I'll change its graphic. I'll make it red because it's for stop. Again, in the switch. Alright, I'll change its hex code too. I'll set its label to stop. So, I've defined the forward and stop switches. I'll paste one more for the reverse switch. Alright, for reverse, I said address 5 should get the value 4. Okay, that's done too. So here, we've defined our switches. Forward, stop, and reverse switches. Now, let's open a box here and bring in a static text, a picture of the inverter itself. We'll click on Import from File. We'll bring in the picture of our inverter. Here, we select Use PNG and click OK. Let's make our inverter image a bit bigger. Alright, we've placed the forward switch. We've placed the stop switch. We've placed the reverse switch. Here, we'll change the label and set it. Reverse. Alright. Now, what we need to do is add an invisible gain input for the inverter's frequency value. So, in the Components tab, we add an invisible gain input value. Okay. For our device type, as we said, we no longer want to use the internal registers in the PLC. We want to communicate with an external device. So again, we set this to COM2, which means Modbus RTU hex. We want to perform both write and read operations. We set it to 4x. The address for frequency in LS inverters, model S100, is address 4 hex, so I set the address to 4 and confirm. Alright, this is what we want. Let's set it on the inverter itself. Look, I'm going to make this smaller. I'm setting it directly on the inverter. I want to know the frequency value directly from the device. So, I've set the frequency value here on the keypad. Here, I want to enter the forward, stop, and reverse commands, so I'm making some settings for the invisible input. I'm specifying that my digit is 2 digits with 2 decimal points. Alright. I've also set my invisible input here. I've configured the communication comms for my setup. I want to use COM2. I've set up a forward button of the RS485 type. One for stop and one for reverse. I also need to upload the program I wrote onto the HMI. So, what should I do? In the Tools tab, I click on the Download option. I wait for the program file to be created and built. After my program file is created, a window pops up. It asks, how do you want to download the program you wrote onto the HMI? So I select USB. Now, as you can see here, the HMI also has a mini USB port. This port is USB on one end and mini USB on the other, meaning the cable I want to use to download the program onto the HMI. It's a cable with a USB connector on one end and a mini USB on the other. The mini USB end connects here, and the USB end connects to your laptop or PC. Alright, now I go back into the software again. I want to do this through USB, or rather the HMI's mini USB port, so I click on the download option. We wait for the download to finish and for my program to be transferred onto the HMI. Alright. Now my program has been transferred onto the HMI. Let's go to the equipment together and test the program we wrote. Here, we have connected a HiTek HMI to an LSS100 inverter through COM2, which is RS485 to the inverter's terminal 5. How will our wiring be set up? On the COM2 terminal, you have 2 pins. One is a positive and the other is B negative, plus a terminal for powering the HMI itself. You connect 24V DC to the positive and negative 24V DC terminals on the HMI. Then, for the COM2 terminal, which is RS485, you connect the A positive pin to the S plus terminal on the inverter and the B negative pin, which is the negative RS485 pin, to the S terminal on the inverter. So, our wiring is set up like this. The A positive terminal of the HMI goes to the S plus terminal, and the B negative terminal goes to the S terminal of the inverter. Alright, I've now uploaded the program to the HMI. You can see that the program we wrote is now displayed on our HMI, and our connection to the inverter is now established through the wiring. The A positive terminal is connected to the S plus terminal, and the B negative terminal is connected to the S terminal of the inverter. Now, I'm going to set a frequency on the inverter. For example, I'll set it to 30. You can see that the number 30 appeared on the inverter's keypad, and now I'm sending the forward command to the inverter. You can see that the inverter started running in the forward direction. I'll wait until it reaches 30. I'm stopping the inverter now. You can see the stop command was sent to the inverter. The inverter is going into stop mode. After it stops, I'll send the reverse command to the inverter. The inverter has stopped. You can see that after the reverse command, the inverter started running in the reverse direction. So, in this program, we were able to set the frequency for the inverter through the HMI and send both start and stop commands for both clockwise and counterclockwise directions to the inverter. So in this video we learned how to figure out what network each HMI communication port supports. We said that we go to the Project tab and select HMI settings. On this page, it shows us which networks are supported by COM1, 2, and 3. And to configure each of the communication ports, we said to go to the Setup tab, select Communication Setting and Local Connection, and then define whichever communication port you want to work with here and set up its related settings. And we mentioned that if we want to use an invisible input, switch, or anything like that in the program, and this invisible input or switch is supposed to communicate with another device, that is, send a command to an external device, we need to know the addresses related to that device. The address is related to the RS-485 network, and here in its settings, instead of selecting the device type as COM2, we choose the one we set up, whether it's COM3, COM1, or whichever we selected. We select the one we configured, and in the address type section, we enter the address that belongs to our slave device or the equipment we want to communicate with in this part. So, in this section, we learned how, using HiTek HMIs under the Modbus RTU protocol and the RS-485 network, we can communicate with another device. Thank you for watching. See you next time.